Hello, fellow Earthlings. Have you ever wondered how our planet came to be? How old is Earth, and what happened before humans walked around? Today, we will take a journey through time. Buckle up as we explore Earth's history using the Geologic Time Scale. It's like a giant calendar for Earth. Imagine a timeline stretching back billions of years. Geologists use this timeline, dividing it into sections called eons, eras, and periods. These divisions help us understand the incredible events that shaped our planet. From its fiery birth to the evolution of life, it's a story full of drama, change, and wonder. The geologic time scale is not just about the past. It helps us understand the present and make predictions about the future. By studying past climate change, for example, we can better grasp the challenges we face today. So, get ready for a mind-blowing adventure through deep time. Let's unravel the mysteries of our planet's past together. Our first stop is the Hadean Eon, the oldest and most chaotic period in Earth's history. Imagine a time when our planet was a scorching inferno. This eon, lasting from about 4.6 to 4 billion years ago, was a time of intense heat, volcanic eruptions, and cosmic collisions. During the Hadean, Earth was forming from a swirling cloud of dust and gas. The planet was constantly bombarded by asteroids and comets. Imagine a cosmic shooting gallery. These impacts generated immense heat, keeping Earth in a molten state. As the bombardment slowed down, Earth began to cool. The molten surface solidified, forming the first crust. But this crust was thin and unstable, constantly reshaped by volcanic activity, and the atmosphere was thick with volcanic gases, and oceans were only beginning to form. The Hadean Eon was a time of incredible violence and transformation, setting the stage for the emergence of life on our planet. It's hard to imagine anything could survive in such harsh conditions, but life found a way. The next chapter in our journey is the Archean Eon, spanning from 4 to 2.5 billion years ago. This eon marks a pivotal turning point, the emergence of life on Earth. While the exact origins of life remain a mystery, evidence suggests that the first life forms appeared during this time. The Archean Earth was still a far cry from the planet we know today. The atmosphere lacked oxygen, and the continents were just beginning to form. However, life found a way to thrive in this alien environment. The first life forms were simple, single-celled organisms called prokaryotes. These microscopic pioneers lived in the oceans, far from the harsh conditions on land. They were incredibly adaptable, surviving on energy sources like sulfur and methane. The Archean Eon also witnessed the formation of stromatolites, layered structures created by colonies of photosynthetic bacteria. These ancient structures are some of the earliest evidence of life on Earth. They show us that life was already shaping the planet's environment billions of years ago. As we journey into the Proterozoic Eon, spanning from 2.5 billion to 541 million years ago, we witness a dramatic transformation: the rise of oxygen in the atmosphere. This oxygen revolution was a game changer, paving the way for the evolution of more complex life forms. During the Proterozoic Eon, photosynthetic organisms like cyanobacteria became increasingly abundant. These organisms released oxygen as a byproduct of photosynthesis, gradually changing the composition of the atmosphere. This increase in oxygen had profound consequences. It led to the formation of the ozone layer, which shielded Earth from harmful ultraviolet radiation from the sun. This protection allowed life to move out of the oceans and colonize land. The Proterozoic Eon also saw the evolution of eukaryotic cells, which are more complex than prokaryotes and contain a nucleus. This development paved the way for the evolution of multicellular organisms, setting the stage for the incredible diversity of life we see today. Section 5. The Phanerozoic Eon. Visible life flourishes. Our journey now enters the Phanerozoic Eon, the most recent and exciting eon in Earth's history. This eon, starting 541 million years ago, is marked by visible life forms, divided into Paleozoic, Mesozoic, and Cenozoic eras. The Paleozoic saw an explosion of ocean life. Plants and animals colonized land. The Mesozoic age of reptiles saw dinosaurs dominate. Dinosaurs evolved into diverse forms. Birds and mammals appeared. The Cenozoic age of mammals saw mammals flourish. Primates, including humans, evolved. The Phanerozoic showcases life's diversity and adaptability. Life has evolved and thrived despite challenges. Section 6. Unveiling Earth's past. Relative dating. How do we know Earth's history? Geologists use techniques like relative dating. Imagine a stack of pancakes. The bottom one was made first. Relative dating works similarly, using rock layers to determine ages. Principles like superposition and fossil succession help geologists. Section 7. Cracking the code of time. Absolute dating. While relative dating tells us the order of events, absolute dating gives us a numerical age for rocks and fossils. This method relies on the fact that certain elements decay at a constant rate over time, acting like natural clocks within rocks. One of the most widely used methods of absolute dating is radiometric dating. This technique measures the ratio of a radioactive parent isotope to its stable daughter isotope in a sample. Since the decay rate is known, scientists can calculate the age of the sample. Different isotopes have different decay rates, making them suitable for dating different time periods. For example, carbon-14 dating is used to date organic materials up to about 50,000 years old. Other isotopes like uranium-238 are used to date much older rocks, even billions of years old. By combining relative and absolute dating methods, geologists have pieced together the history of Earth. From the formation of the planet to the evolution of humans, this timeline provides a framework for understanding the incredible journey of our planet. Section 8. Earth's Climate. A Story of Change. Our journey through time wouldn't be complete without discussing Earth's climate. Throughout its long history, Earth's climate has fluctuated dramatically. There have been periods of extreme cold, known as ice ages, and periods of remarkable warmth. These climate fluctuations are driven by a complex interplay of factors, including variations in Earth's orbit, volcanic activity, and the composition of the atmosphere. Greenhouse gases, such as carbon dioxide and methane, play a crucial role in regulating Earth's temperature. Over the past century, human activities such as burning fossil fuels have released massive amounts of greenhouse gases into the atmosphere. This has led to a rapid increase in global temperatures, a phenomenon known as global warming. The consequences of climate change are already being felt around the world, from rising sea levels to more extreme weather events. Understanding Earth's past climate helps us predict future changes and develop strategies to mitigate the impacts of climate change. Section 9. Our role in Earth's future. Reflecting on our place in Earth's history, we see our profound impact despite our recent arrival. We are changing the climate, altering landscapes, and driving species to extinction. Our choices today shape the future. Let's create a sustainable future for all life. Thank you for joining me. Keep exploring, questioning, and caring about our planet.